Mike, I've completed all the tests in the manner we've outlined, and I'm ready to analyze the data. Here's a table of the results. Shrinkage values range from 14 to 27%.
Good. I'll take the data, do some calculations, get back to you later.
Thanks. That'll give me some time to make some phone calls.
Dick, have the results. Look pretty interesting.
Oh, what took you so long? Sam's been bugging me about giving him the results.
Well, relax, and I'll explain what I did. Now, the complete analysis of this experiment is somewhat involved, but let me explain some of the key elements of this type of experimental design by examining only a portion of the results. Now, let's focus on two of the variables, screw speed and holding pressure. Now, this can be thought of as 2 to the power of 2 factorial, which geometrically can be represented as a square. Now, the 4 tests required are the corners of the square. Now, in this geometric representation, there are 2 comparisons that we can make which say something about the effect of holding pressure when screw speed is held constant. At a low level of screw speed, increasing holding pressure increases shrinkage by 0.9%. At a high level of screw speed, increasing holding pressure increases shrinkage by 10.1%. Then on the average, increasing holding pressure increases shrinkage by 5.5%. And we call this the average main effect on holding pressure. We can do a similar calculation with the screw speed. In this case, the average main effect of screw speed is, it's like 1.2%.
Hey, this is simple. Let me see if I understand. On the average, increasing holding pressure increases shrinkage, and increasing screw speed increases shrinkage. Then to reduce shrinkage, we should reduce both holding pressure and screw speed.
Well, we have to be careful here. Look at the results more closely. If we examine the screw speed effect more carefully, we see that it is different, depending on the holding pressure. When holding pressure is low, increasing screw speed actually decreases shrinkage. But when holding pressure is high, increasing screw speed increases shrinkage. The average main effect of screw speed alone is somewhat deceiving. These 2 variables interact in terms of how they influence shrinkage. Now, we can determine the degree of interaction by looking at the average difference in the individual main effects. At low holding pressure, the increasing screw speed decreases shrinkage by 3.4%, whereas at high holding pressure, increasing screw speed increases shrinkage by 5.8%. Now, the average difference in these 2 effects is therefore large, 4.6%, which means that a strong 2-factor interaction is present. And we can represent the average main effect and interaction effect information we've obtained from the experiment as an equation to predict shrinkage as a function of holding pressure and screw speed. Shrinkage at any given values for holding pressure and screw speed is equal to the average of the 4 tests forming the square, plus the average main effect of holding pressure over 2 times the holding pressure, plus the average main effect of screw speed over 2 times the screw speed, plus the interaction effect between holding pressure and screw speed over 2 times the product of holding pressure and screw speed. Numerically, this equation is percent shrinkage equals 19.75 plus 5.5 over 2 times holding pressure, plus 1.2 over 2 times screw speed, plus 4.6 over 2 times holding pressure times screw speed. Now, we notice 2 things about this equation. 1, the interaction effect coefficient is quite large. It is a significant part of the equation. And 2, in terms of the square, shrinkage is predicted to be smallest when holding pressure is at its minus level and screw speed is at its plus level. Because of the presence of this strong interaction, shrinkage is not lowest when both holding pressure and screw speed are at low levels. Actually, the combination of high screw speed and low holding pressure will tend to reduce shrinkage the most. It's the interaction between the screw speed and holding pressure that's the key here.
But it seems we ran this test at the very beginning. Why didn't we see it then?
Well, we did run this test, but because we were testing in such a haphazard fashion and not running experiments, we didn't realize what we had. When you increased screw speed to rerun the mold temperature tests, we got 2 different shrinkage percentages. Now, you were so preoccupied with finding a nice temperature effect that you shrugged off the downward drift in holding temperatures during the test. You thought it messed up the test, so you quickly increased the holding pressure. When you did that, shrinkage increased greatly. The screw speed you thought was unimportant turned out to be quite important. Further, it was the interaction between holding pressure and screw speed that is the key here to solving the problem. Well, the one factor at a time experiment you wanted to run would never have revealed this.
You really know how to turn the screw.
Well, I just hope you learned something from the experience.
Hey, I really have. Hey, Sam will be so pleased with my performance on this project. See, I know you're busy. I'll save you the time and show Sam the results myself.
Wait, I'm coming with you.
Oh, really?
I'm very pleased with the teamwork you two have displayed. Dick, with your experience in plastics, and Mike, with your background in statistics, you've been able to come up with a solution to the problem. Thanks. I'll pass the information on to everyone concerned.